Let's consider another word problem. The logistic growth function f of t is equal to 140 divided by 1 plus 9 times e to the negative 0.165 t. This describes the population, f of t, of an endangered species of elk t years after they were introduced to a non-threatening habitat. Part A says, how many elk were initially introduced to the habitat? Now let's look at Part A. How many elk were initially introduced to the habitat? Let's go up to our function here. We want to find out how many elk we started with in this particular region. Well, mathematically, we can represent that as f of 0. So if we plug that in there, we have 140 all over 1 plus 9 times e to the negative 0.165 times 0, which is going to be simply e to the 0, since we're replacing t with 0 in this problem. We know anything to the 0th power is 1, so we can write this as 140 all over 1 plus 9, or 10. So we know that our initial population, when we started out with, was 14 elk. Now let's consider Part B. How many elk are expected in the habitat after 10 years? Well, we're going to use our function once again for Part B, and we can evaluate this as being f of 10. So we'll plug this into our formula, 140 all over 1 plus 9 times e to the negative 0.165 times 10 power. So this then becomes a calculator problem. You have to be very diligent when you're plugging these in, very careful. Use a lot of parentheses when you're trying to calculate that. But when all said and done, we're going to come up with a number of approximately 51 elk after that 10-year period. So this completes Part B. Now let's finish our problem. Part C says, what is the limiting size of the elk population that the habitat will sustain? All right, going to our function here, basically we're going to let t go to infinity. As t goes to infinity, the exponential goes to 0. So we can imagine, as this t value gets larger and larger, our fraction will look something like the following: 140 over 1 plus 9 times 0, or simply 140. So that will be the limiting size of the elk population that this particular habitat can sustain.